An optical fiber or optical fiber is a flexible, transparent fiber made by drawing glass or plastic to a diameter slightly thicker than that of a human hair. Optical fibers are used most often as a means to transmit light between the two ends of the fiber and find wide usage in fiber optic communications, where they permit transmission over longer distances and at higher bandwidths than electrical cables. Fibers are used instead of metal wires because signals travel along them with less loss. In addition, fibers are immune to electromagnetic interference, a problem from which metal wires suffer excessively. Fibers are also used for illumination and imaging and are often wrapped in bundles so they may be used to carry light into, or images out of confined spaces, as in the case of a fiberscope. Specially designed fibers are also used for a variety of other applications, some of them being fiber optic sensors and fiber lasers. Optical fibers typically include a core surrounded by a transparent cladding material with a lower index of refraction. Light is kept in the core by the phenomenon of total internal reflection, which causes the fiber to act as a waveguide. Fibers that support many propagation paths or transverse modes are called multimode fibers, while those that support a single mode are called single-mode fibers. In the late 19th and early 20th centuries, light was guided through bent glass rods to illuminate body cavities. Practical applications such as close internal illumination during dentistry appeared early in the 20th century. Image transmission through tubes was demonstrated independently by the radio experimenter Clarence Hansel and the television pioneer John Logie Baird in the 1920s. In the 1930s, Heinrich Lamb showed that one could transmit images through a bundle of unclad optical fibers and used it for internal medical examinations, but his work was largely forgotten. Achieving a high data rate and covering a long distance simultaneously is challenging. To express this, sometimes the product of data rate and distance is specified, bits per second times km or the equivalent bit times kilometer per second, similar to the bandwidth distance product. 2006, Nippon Telegraph and Telephone transferred 14 terabits per second, bit, s, over a single 160 km long optical fiber, 2.2 bit/s middle.km. 2009, Bell Labs in Villars-Arcs, France transferred 15.5 terabits per second over 7,000 km fiber, 108 bit/s middle.km. 2010, Nippon Telegraph and Telephone transferred 69.1 terabits per second over a single 240 km fiber, 16.5 bit/s middle.km. 2012, Nippon Telegraph and Telephone transferred 1 petabit per second over a single 50 km fiber, 50 bit/s middle.km. An optical fiber is a cylindrical dielectric waveguide that transmits light along its axis, by the process of total internal reflection. The fiber consists of a core surrounded by a cladding layer, both of which are made of dielectric materials. To confine the optical signal in the core, the refractive index of the core must be greater than that of the cladding. The boundary between the core and cladding may either be abrupt, in step index fiber, or gradual, in graded index fiber. Attenuation in fiber optics, also known as transmission loss, is the reduction in intensity of the light beam as it travels through the transmission medium. Attenuation coefficients in fiber optics usually use units of decibel/km through the medium due to the relatively high quality of transparency of modern optical transmission media. The medium is usually a fiber of silica glass that confines the incident light beam to the inside. Attenuation is an important factor limiting the transmission of a digital signal across large distances. Thus, much research has gone into both limiting the attenuation and maximizing the amplification of the optical signal. Empirical research has shown that attenuation in optical fiber is caused primarily by both scattering and absorption. Single-mode optical fibers can be made with extremely low loss. Corning's SMF28 fiber, a standard single-mode fiber for telecommunications wavelengths, has a loss of 0.17 dB/km at 1550 nanometers.